We are in Module 1. This is Section 4, and we are talking all about electrical safety. And so they want you to know that less than 1 amp of electrical current, it can be enough to kill you. Right? It doesn't take much because electrical current can mess with your heart. Even like the little prank things where it's like a fake stick of gum and it shocks your friend. I mean, if their heart is messed up, that could cause to get out of rhythm or cause a heart attack or something. You never know. I've gotten shocked by outlets and light switches more than once. I'm still alive to tell about it. I know people have gotten shocked by bigger voltages than that. But you never know. You want to avoid getting shocked at all times. You don't purposely put yourself in a situation where you're going to get shocked. And so here you can see a watch battery is only 0.001 amps. A 9-volt battery, I don't know if you ever tried this, but if you put it on your tongue, a 9 volt's the square one that has the 2 things on the end. Like, you put that on your tongue, it'll shock your tongue. Little side thing, science experiment. You can see Christmas tree bulb, painful shock, right? Small electric radio. And so here, 1 amp. We're looking at these tools, the different tools we got, they're over 1 amp of power. And so these things can do serious damage to you if they shock you the right way. So just be aware when working around electrical, avoid getting shocked, do the proper safety things we're going to talk about. A GFI, or a ground fault circuit interrupter. All right. So what this is there, if you can see, there's a test and a reset button. So what happens is if there's a surge of electricity or there's an arc or something, this thing senses it, or something's overheating, too much power is being drawn, this thing will sense it and it trips. It's like a light switch that's automatic. Or think of the breakers in your basement or in your bathroom or kitchen. Those outlets probably have these kind of GFI outlets because it's by code. And so it means that just if there's some kind of shocking situation happening, it shuts itself off. It disrupts the circuit. So it's a circuit interrupter. So it'll break the circuit and turn whatever it is off. So the power is no longer getting here. And so when you're using tools, this is a fairly common thing. You want to have one of these in place. That's to protect that you don't overpower a circuit in the house, because lots of times these tools are drawing a lot of amperage and a lot of power, but also protect you. If you cut your cord, instead of it continuing to shock you, it's going to shut itself off. So it's just saying you can test these things. You know, if you have power, if you can test and reset, that means their power is going through. So that's what one of these things is. Other ways that people who can do this is just normal. See how it has 3 prongs right here? You have your 2, and then the third, this is your ground. And so that's a normal way to ground things. Some tools are double insulated. If they don't have that ground, they're just the 2-prong, that means they're double insulated. Just another way to protect yourself from getting electrocuted. But so remember, this is to interrupt the current if there's overpower or a shock situation. Here we can see you want to use ground fault if you can. Never use bare electrical wire, so you shouldn't. It's against OSHA to make your own wires. Or if you mess up a cord, you shouldn't replace that cord from anything but a factory replacement. Right? You want to hardwire it back in. You don't want to just use a plain wire and turn that into an extension cord. You want to make sure everything is factory. And that's just for safety, because you don't want to get anyone hurt or shocked. So let's see. Again, don't use frayed cords. You always want to inspect an extension cord, see if there's the coating, the protection on it is worn through. See if the ends are messed up. If sometimes the ground thing, the 3rd pin breaks off and gets stuck, or it's missing that, can't use it. You got to make sure it is up to factory standard. And so when you're working around power is there a picture one? Here we go. We got lockout, tagout. And so this is how you protect yourself on a job site. If you're working, there's a bunch of people around. What you do is you put one of these, and see, this is locking out the thing. You can't turn the valve back on. This one's a pneumatic one. Here's an electrical, and you put it over the breaker. Basically, you put a deadbolt. What is that called? One of these things, these locks, whatever that word is. You put one of them on it, and so no one else can turn the power back on. So you're going to turn off that breaker so you can do something in the house. You're wiring lights or something. And so you don't want anyone to come back on and be like, oh, my lights aren't working, and hit the switch to turn it on. You get majorly shocked that way. So make sure you have lockout, tagout is what that's called. And you write a tag, you say who you are, what you're doing, how long you'll have it unlocked, and you're the only one who's allowed to unlock it. No one else can go and unlock it, right? Only you. And see how this has more than one hole? So this, say you have it locked out and you're working on it. So you have your lock. And then someone else comes and he's going to be working on the same circuit. He doesn't trust you. He's going to put his own lock on it because you might be done before he is. And so you undo yours and turn the power back on and he's still working on it. So that's why there's these multiple holes, because this is where your lock is going to go. So that's what lockout tagout is. And again, you always want to do that if you are working in a situation where there's other people who are going to be working around you. So you can work on overhead power lines. There's special equipment that you can use, special insulated gloves and things to keep them live. If best, you can turn them off. And you always want to maintain at least a distance of 10 feet from them, especially in a metal basket, like in a boom truck or something. You do not, or crane work, you do not want to get within 10 feet because the high voltage lines, they can arc. Even though you're not touching them directly, it can arc and touch the metal and fry you. So always be really careful. Keep all your equipment and everything at least 10 feet away. Make sure you're paying attention to that. Here's other forms of lockout tagout. There's different things. That's what we got for electrical. So be safe, turn off your breakers, don't work on stuff live. If you have to, make sure you have the proper equipment so that you don't get shocked. Special insulated gloves, special tools, and make sure your equipment is always not broken. Check your wires before you use them. Make sure they're not frayed. Make sure no wires exposed. Make sure there's factory ends. Make sure the pins aren't missing and all those kind of things. Make sure you're doing the safe things because it's not worth the risk. Some people might just laugh and say it just hurts a little bit, but you never know. It could be that one time when it stops your heart. So make sure you're paying attention and being safe. And that is your basic electrical stuff.